I am Rachel Jean Casrinavi, and for today's lecture, we will going to discuss the negative binomial distribution, Poisson distribution, and normal distribution. Let's have first the learning objectives. At the end of the lesson, the student is able to understand the concepts in negative binomial distribution, Poisson distribution, and normal distribution. The second learning objective, the student was able to describe the methods and provide examples. The third, the student was able to derive the formulas. Let's discuss the negative binomial distribution. Negative binomial distribution, also known as the Pascal distribution. It is the probability distribution of a negative binomial random variable. It describes the number of trials required to generate an event a particular number of times. When you provide an event probability and the number of successes k, this distribution calculates the likelihood of observing k successes of the nth attempt. There are different notations that we need to remember in the negative binomial distribution, and these are the following notations. N is the number of trials required to produce k successes in a negative binomial experiment. K, the number of successes in the negative binomial experiment. P, the probability of success on an individual trial. Q, the probability of failure on an individual trial. This is equal to 1 minus P. N factorial, the factorial of n, also known as the n factorial. These different notations are very important to remember in answering problems about negative binomial distribution. Let's proceed to the negative binomial formula. Negative binomial formula. Suppose a negative binomial experiment consists of n trials and results in k successes. If the probability of success on an individual trial is p, then the negative binomial probability is, we have the probability mass function. P, x is equal to n is equal to n minus 1 combination k minus 1, p to the power of k, 1 minus p to the power of n minus k. In getting the mean, we have the expectation of x is equal to k over p. In getting the variance, we have variance of x is equal to k, 1 minus p over p squared. Next, let's proceed to the different examples. We have two examples given, and we can use these formulas, these very important formulas in solving the problem. Before I forgot, we have the following properties. There are four following properties. There are a lot of following properties, but we will focus more on these four. Okay, we have a negative binomial experiment. It's a statistical experiment that has the following properties. First property is the experiment consists of n repeated trials. Second property is each trial can result in just two possible outcomes, success and a failure. Third property is the probability of success denoted by k is the same in every trial. The trials are independent. That is, the outcome of one trial does not affect the outcome on other trials. In solving negative binomial distribution, these following properties are very important. These are very essential, very important to remember. Okay, let's proceed to the example number 1. Example number 1, we have Jim is writing an exam with multiple choices questions, and his probability of attempting the question with the right answer is 60%. What is the probability that Jim gives the third correct answer for the 5th attempted questions? Okay, for the solution, it is very important to identify first the different given, the probability, the failure, the number of trials and then the success. First, we have P. It is the probability of success. We have there the right answer is 60%. So automatically 60% is our P, and then the number of failure is automatically 40% or 0.40. Our N, or the number of trials, is equal to 5. And then our K, or the number of successes, is equal to 3. Then, for the solution, we have the formula. This formula is very important. It's very applicable in getting the solution, in getting the answer of the problem. We have P, X is equal to N minus 1, K minus 1. P to the power of K, 1 minus P, N minus K. Okay, let's going to substitute the givens. Givens above. Okay, we have X is equal to 5. 5 is our N, or the number of trials, is equal to 5 minus 1, K minus 1. Our probability there is 0.60, then K is 3. We have the number of failure is 0.40, and then we have 2. Okay, so this one, 5 minus 1 is equal to 4, 3 minus 1 is equal to 2. Then we will just copy this one, and then we have for combination 2. For combination 2, we will going to calculate that one, that is equal to 6. And then 0.60 cubed is equal to 0.216. 0.40 to the power of 2 is equal to 0.16. And then we will going to multiply this 3, and this is equal to 0.1296 multiplied by 0.16, and this is equal to 0.020736. Now, therefore, the probability of giving the third correct answer for this fifth attempted question is 0.02. Let's proceed to the example number 2. Example number 2, we have an oil company conducts a geological study that indicates that an exploratory oil well should have a 20% chance of striking oil. We have A. What is the probability that the first strike comes to the third well drilled? B. What is the probability that the third strike comes to the seventh drilled? C. What is the mean and the variance of the number of wells that must be drilled if the oil company wants to set up 3 producing wells? Let's answer first the question A. What is the probability that the first strike comes on the third well drilled? Okay, so we have the solution. We have the given first. P is equal to 0.20. Automatically, our Q, or the number of failure, is 0.80. N, or the number of trials, we have 3. And then our K is equal to 1. We have here the solution. The solution P, X is equal to N. We have the formula, the very important formula. And then P, X is equal to 3. Our number of trials is equal to 3. And then it is equal to 3 minus 1, then 1 minus 1, 0.20. No? We will just going to substitute all our given. 0.20 to the power of 1, 0.8 to the power of 2. And then substitute again, we get 2 combination 0, 0.20 to the power of 1, 0.80 to the power of 2. And then it is equal to 0.128. In any case, there is 30% chance that the first strike comes and the third will fail. No? For the question, what is the probability? The probability of the first strike comes and the third will fail. So the answer is, the probability is 0.128. Okay, let's proceed to B. We have the same problem, but we have different question. No? We have here, what is the probability that the third strike comes on the 7th well drilled? The solution, we have the given P is equal to 0.20 again. In the given example, our P there is 0.20, so nothing changed. P is 0.20, still Q is 0.80. The one changes is the number of trials and then the number of success. We have N is 7, since in the given we have on the 7th well drilled, so we have the number of trials 7, and then the third strike we have our K, or the number of successes, is 3. We have the solution, we have the formula, and then again we will just going to input all the given. We have 7 minus 1. P, x is equal to 7. 7 minus 1 combination, 3 minus 1, 0.20. Cube, 0.80 to the power of 4 is equal to, we have 6 combination 2, 0.20 cube, 0.80 to the power of 4. And then if we were going to solve this one, and the answer is 0.049152. Therefore, the probability that the third strike comes on the 7th well drilled is equal to 0.049152. Okay, let's proceed to C. We have the question, what is the mean and the variance of the number of wheels that must be drilled if the oil company wants to set up 3 producing wheels? Okay, for the mean we have the formula. Mean is EX is equal to K divided by P. Simply, our number of successes is 3 divided to our probability is 0.20. 3 divided by 0.20 is equal to 15. So our mean is 15. And then for the variance, we have the formula, and then we will going to input our given 3, or the number of success we have 3, and then the number 1 minus P is the failure. We have 0.80 over the number of the probability 0.20 to the power of 2. 3 multiplied by 0.80 divided by 0.20 to the power of 2 is equal to 60. Therefore, the mean of the wheels is 15 with the variance. The mean of the wheels is 15 with the variance of 60. That will be our example number 1 and number 2. Let's proceed to the exercises. We have 2 prepared questions on the exercises. First, you are surveying people from a polling booth and asking them if they voted independent. The probability that a person voted independent is 20%. What is the probability that 15 people must be asked before you find 5 people who voted independent? And for the second question, the probability of Ron going on time to school is 80%. What is the probability that Ron goes on time for the 8th time for the first 10 days of school? In solving this one, simply use the formula, then substitute, and then that's all for the concepts, definitions, and examples about negative binomial distribution.